Hello and welcome. This is going to be our lecture video for this packet here, the mole conversion worksheet. We'll just go over a handful of these problems, make sure you're understanding this, starting with some mole particle conversions. So number one, how many moles of magnesium is 3.01 times 10 to the 22nd atoms of magnesium? Whenever we're given a number, it's very likely we want to just write that number in the top left spot of a unit conversion bar and make sure to include its units. So it's 3.01 times 10 to the 22nd atoms. Next, we'll write our desired unit of moles at the top and atoms at the bottom. And now we just need to put in a unit conversion here that is true. I know that 1 mole is equivalent to 6.02 times 10 to the 23rd atoms. This is Avogadro's number, and it tells us how many particles are in a mole, be it atoms or molecules or whatever you want. Now, to actually evaluate this unit conversion bar, we're going to take the number on top and then divide by the number down here. So with unit conversions, especially large unit conversions, the idea is multiply all the way across the top, multiply all the way across the bottom, and divide. So if I have a very long unit conversion with many numbers in it, the idea is multiply, then multiply across the bottom, multiply, and then divide. Now, another tip for this is that when you plug this into your calculator is you should be using parentheses. So parentheses 3.01 times 10 to the power of 22. There should be a little caret button or some way for you to put in exponents, divided by, in parentheses, 6.02 times 10 caret 23. That's how you should plug that in to your calculator. All right, and plug it in, write down what you get. So now we'll go the other direction with number 2. How many molecules are in 4 moles of glucose? So we're given the information we have 4 moles. And we want to go back to molecules. Well, again, I'll use the same conversion, but I'll put moles on the bottom. And then Avogadro's number on top. This way, moles will cancel, and I'll be left with the number of molecules. And so technically, it's 6.02 times 10 to the 23rd particles per mole, but I'll write molecules because that's the type of particle that I want in this problem to end up being my final unit. And I'll let you multiply those. Do write your answer in scientific notation. It should be like 2.4 times 10 to the 24th molecules. And always remember to include your unit. All right, next page. All right, and here we are in the next page. Now that we've practiced both going from molecules to moles and moles to molecules, let's do some moles to mass conversions. So how many moles in 28 grams of CO2? So if we ever have information about mass and moles, we need something called the molar mass. So we need to be able to figure out the molar mass of carbon dioxide. So molar mass. And to calculate that, we will do the mass of 1 carbon plus 2 times the mass of oxygen. If you plug it into your calculator like this, it'll do the order of operations correct. You do need to multiply before you add. And I'm going to plug this in and figure out what it is. And I got that carbon dioxide has a molar mass of 44.009 grams per mole is the unit there. So always remember to write down your unit. Now we can go back to our unit conversion bar. We're starting with 28 grams, and we want to end up with moles. So we'll put grams on the bottom, moles on top. That way grams cancels. And at the bottom, we'll write 44.009 grams is equivalent to 1 mole. Now to evaluate this, we are going to do 28 divided by 44.009. and I get 0.636, and my new unit here is moles, which answers the question, how many moles? 0.36 moles. All right, mass of 5 moles. So now we're going the other direction. Again, we got to find the molar mass here. So 2 times the atomic mass of iron, which is 55.845, and then plus 3 times the atomic mass of oxygen, 15.999. And what do we get? 55.845 plus 3 times 15.999, 159.687 grams per mole. But now this time we don't have to flip that upside down because we have moles on top and we want to end with grams on top. So it's 159.687 grams per 1 mole. And we end up just multiplying this number by 5. If you still got that number in your calculator, you can just multiply it by 5 and get 798 grams. That's our unit here. All right, we got another one of converting moles, 2 moles, 2 grams. And in this one here, just they made it a little tricky. You have to remember that how to come up with the chemical formula when just given the name. This is just 1 lithium and 1 bromine in a lithium bromide molecule. All right, mole to volume conversions. So for this, we really need to know that 1 mole of a gas is always going to equal 22.4 liters at STP, which stands for standard temperature and pressure. So here, when we start with 0.03 moles, we can just put that in the top left, and then we can say 1 mole, to cancel out moles down here, is equivalent to 22.4 liters. Multiply, and we get our answer, 0.03 times 22.4 is 0.672 liters. All right, let's go the other direction where we're given liters, so 11.2 liters, and then we'll just put our unit conversion in there the other direction. 1 mole is equivalent to 22.4 liters. We end up dividing and we get 0.5 moles for this one. All right, next page. All right, let's start looking through this mixed practice and see if there's anything that throws us off. Moles to grams, we've done that. Grams to atoms, this one requires 2 steps, so let's look at this real quick. We're starting with 1.6 grams. We need to get it to moles first because we do know how to do that calculation. Sulfur has a molar mass of 32.06 grams per 1 mole. And then we can go moles to atoms by knowing that 1 mole is 6.02 times 10 to the 23rd atoms. And here's a case where we have to multiply across the whole top, multiply across the whole bottom, and divide. It's 1.6. Let's make sure all of our units cancel, grams cancel, and moles cancel. And our final answer will be in atoms. All right, number 3 says grams to moles. We know how to do that. Grams to moles. All right, number 5 says it's got an extra step, so let's read this one carefully. You find the mass of the cans in the box you have brought has a mass of 23 kilograms. How many moles do you have? So the slight difference here is that we normally do our calculations in grams, but we have 23 kilograms of tin. So let's just do a quick calculation to get that back into grams. We know that there's 1,000 grams in 1 kilogram, and now kilograms cancel, and we'll have 23,000 grams. And then tin, SN has a molar mass of 118.71 grams per 1 mole. And so you end up doing 23,000 divided by 118.71, and you'll get the number of moles of tin. All right. So at number 6, so we want to figure out if we drink 2 liters, I'll just write down 2 liters, how many moles is that? We know 2 liters is 2,000 milliliters because there's 1,000 milliliters to 1 liter. And we know that 1 milliliter is 1 gram because that's the density of water. And we know that water is 18 grams per 1 mole. Multiply across the whole top, we'll get 2,000. Multiply across the whole bottom, we'll get 18. 2,000 divided by 18 is 111.1. And our unit there is moles because everything else canceled, and that's what we wanted to get. All right. You can pick any atom you want for number 7. Grams to moles. Grams to moles, and number 10, converting moles back to grams. All right, we've practiced all of that. Let's move on. All right, and let us now do some multiple variable conversions. We've got liters to molecules. So we're starting with 3.36 liters of gas, which now we can use the standard temperature and pressure conversion. That 22.4 liters of gas at STP is equal to 1 mole of gas. And then we will use Avogadro's number to convert 1 mole to 6.02 times 10 to the 23rd of molecules. All right, next one, we have molecules to grams. So we'll start with our 2 times 10 to the 23rd molecules. And then the only thing we know how to turn molecules into is moles. We'll use the fact that it's 6.02 times 10 to the 23rd molecules to 1 mole. And then to go moles to grams of F2, we need the molar mass of F2. So 2 times the atomic mass of fluorine of 18.998. And that is, get that calculator back out, 2 times 18.998 is 37.996 grams per 1 mole of fluorine gas. I will plug this one in, and you should try it too, just so we can make sure we're all doing that scientific notation correct. So in parentheses, 2 times 10 to the power of, you gotta find that exponent button. If you're using your phone as a calculator, turn your phone sideways. So 10 to the 23rd times 37.996. I'll close the parentheses there, divided by, in parentheses, 6.02 times 10 to the 23rd, close parentheses, and I get 12.62 grams. So 12.62 grams of gas in this sample. All right, next we're going to do grams to liters. I'll set that one up. So 14 grams of nitrogen. Now we need to convert it to moles. You do have to know that nitrogen gas is N2. And there will therefore have a molecular mass of, 28.014 grams per mole. So 28.014 grams per 1 mole. And now we'll use the STP calculation to say that 1 mole is equal to 22.4 liters. Multiply, and divide. And we'll have the answer number 3. All right, molecules to grams. Again, you got to go via moles to get that one done. grams to particles, use the molar mass to get moles, and then convert that to number of molecules. In this one, the molar mass, you don't know what the substance is, but you know it's 233 grams. They really should say that that's 233 grams per mole. I think it's implied by saying that that's the molecular mass, but they should still include that in the unit. All right, and number 6. So calculate the molar mass of aspartame. So it's C14H18N2O5. So to figure this out, we have to do 14 times the atomic weight of carbon plus 18 times the atomic weight of hydrogen. I'm just using parentheses to show multiplication here. And then the number of the atom becomes the coefficient. Nitrogen is 14.007. And then oxygen is that 15.999 number. All right, if we plug all of that in, we will get the molar mass of aspartame here. I'm going to do it in my own calculator. We'll see if we get the same answer. And I got 294.307 grams per mole for aspartame. Now to convert to molecules, we'll just start with our 10 grams. Convert to moles first. 1 mole is 294.307 grams. And then we'll go moles to molecules using, again, Avogadro's number. All right, and then moles back to grams, just reverse the molar mass. 5 milligrams. We want to work in grams, so know that it's 1,000 milligrams to 1 gram. So that helps to get into grams, and then we can use the molar mass to go back to moles, and then Avogadro's number again. And then atoms of nitrogen, you'll figure out the number of molecules, and then you just multiply by 2 because there's 2 nitrogens in every aspartame. All right, well, let's call that good for this lecture video. Have a good rest of your day.